Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0098 indicates a high voltage condition in the intake air temperature IAT sensor 2 circuit. This malfunction begets a response from the powertrain control module, PCM, which registers the anomaly within the IAT sensor output voltage. The IAT sensor is crucial as it helps the PCM calculate the correct air-fuel mixture for optimal engine performance. It is situated within the intake air path or manifold, allowing it to measure the temperature of the incoming air. A higher than expected voltage from IAT sensor 2 signifies a fault that could stem from the sensor itself, the circuit connecting it, or the PCM. In this presentation, we will delve deep into understanding the symptoms, causes, and step-by-step troubleshooting needed to resolve this issue. The intake air temperature IAT sensor 2 is a critical component in the engine management system of the Honda CR-V, particularly influencing air-fuel mixture calculations performed by the powertrain control module, PCM. This sensor is physically located within the intake air path or manifold. Its main role is to measure the temperature of incoming air, allowing the PCM to make informed adjustments to optimize engine performance. When the IAT sensor 2 outputs a voltage higher than specified limits, specifically above 4.92 volts, the PCM interprets this as an anomaly, thus triggering the DTC P0098. The abnormal voltage can signal potential issues in the sensor, wiring, or the PCM itself, leading to performance inefficiencies if not addressed properly. Several issues can lead to the DTC P0098 appearing in your Honda CR-V. The first possible cause is a faulty IAT sensor 2, which could have failed internally, resulting in incorrect voltage readings. Next, damaged or frayed wiring connecting the sensor to the PCM can introduce resistance or short circuits, mimicking a faulty sensor condition. Thirdly, if both the IAT sensor and the wiring are in good condition, the problem might lie with the PCM itself, which may not be interpreting the sensor data correctly due to internal defects. Thoroughly checking each component is essential to pinpoint the root cause of the DTC and apply the necessary repairs. When DTC P0098 is triggered in the Honda CR-V, drivers may notice several symptoms. One of the most common is poor engine performance, which may manifest as hesitation, stalling, or rough idling. As the PCM attempts to adjust fuel ratios based on inaccurate sensor data, performance issues arise. The check engine light will also illuminate, providing a clear indication that a diagnostic code has been registered. Additionally, there may be increased emissions due to improper air-fuel mixture adjustments, which could potentially lead to failing an emissions test. Being aware of these symptoms allows for timely intervention before more severe engine issues develop. The first step in troubleshooting DTC P0098 requires putting the vehicle in the on position without starting the engine. This allows for the activation of the vehicle's electrical systems without engaging the engine. Next, utilize the Honda Diagnostic System, HDS, to monitor the IAT sensor 2 voltage in real time. If the displayed voltage exceeds 4.92 volts, you have successfully replicated the failure condition. This observation confirms that the sensor output voltage is indeed high, prompting further investigation into the specific components involved. If the voltage is within normal parameters, the issue may lie elsewhere in the wiring or PCM. In the second step of the troubleshooting process for DTC P0098, begin by disconnecting the IAT sensor 2 connector, specifically the 2-pin connection. This disconnection is crucial as it isolates the sensor from the vehicle's electronic systems. Subsequently, jumper wire terminals 1 and 2 of the IAT sensor connector together, effectively mimicking the sensor's operation. After this, turn the vehicle to the on position once more to engage the electrical system. Utilize the HDS to confirm that the IAT sensor 2 voltage is now below 4.92 volts. If so, it indicates that the issue lies within the IAT sensor itself. Conversely, if voltage remains high, further circuit assessment is necessary. The following troubleshooting step involves inspecting the ITA2 INTA circuit for possible open wires. Before starting this inspection, ensure both the IAT sensor 2 and the powertrain control modules, PCM, connectors are disconnected. This is important to avoid any erroneous readings during the inspection. You'll be looking for continuity in the wiring between the IAT sensor and the PCM. According to specifications, you should find a resistance of less than 1 ohm, indicating a good connection without any breaks in the wire. If the circuit shows any signs of an open wire or higher resistance, then the wiring will need to be repaired or replaced to resolve the issue, triggering the DTC. Continuing the P0098 troubleshooting process, the next step involves inspecting the ground GND wire known as SG2. Establish a connection to the SG2 line and measure the resistance just like before. It should also read less than 1 ohm to confirm a solid ground connection. This is vital because any integrity issues with the ground circuit could lead to inaccuracies in sensor voltage readings. Should the inspection reveal higher resistance or an open circuit in the SG2 wiring, repairs must be initiated. This process ensures that every component connected to the IAT sensor is functioning correctly, preventing unnecessary replacements of components that are not at fault. If all previous tests yield normal results, indicating that both the IAT sensor and wiring are functioning as expected, the focus shifts to the PCM itself. At this point, you'll need to assess the PCM for any internal faults. It's crucial to analyze the data output and confirm that the PCM is receiving input correctly from the IAT sensor. If the PCM fails to interpret the data appropriately, it may be necessary to consider replacing it to rectify the DTC P0098 condition. Confirming PCM functionality is a critical step, as a malfunctioning PCM can emit a range of fault codes, ultimately affecting vehicle performance and drivability. Upon determining and executing the necessary repairs related to DTC P0098, it is important to perform a final verification. Begin by clearing the DTC using the Honda Diagnostic System. Following this, you should retest the vehicle to confirm that the IAT sensor is providing accurate readings below 4.92 volts. It is advisable to monitor the data closely during a short drive and watch for any reemergence of the DTC. Validating that the IAT sensor function returns to normal ensures that the issue has been resolved and greatly reduces the likelihood of future complications stemming from the same circuit. To prevent the recurrence of issues relating to DTC P0098 in your Honda CR-V, regular maintenance is essential. Make it a routine practice to inspect the intake air temperature sensor periodically for any signs of wear or damage. Additionally, routinely checking the wiring harnesses connected to the IAT sensor and PCM can preemptively catch issues before they escalate. Furthermore, ensuring that your PCM firmware is updated is equally critical, as software updates may resolve underlying bugs that affect performance. These preventive measures not only enhance the reliability of your vehicle, but also promote optimal performance and fuel efficiency. In conclusion, understanding and addressing the DTC P0098 is vital for maintaining the performance of the Honda CR-V. A high voltage condition in the intake air temperature sensor 2 circuit can lead to various performance issues if neglected. By meticulous troubleshooting, it's possible to pinpoint whether the fault lies within the sensor, the wiring, or the PCM. Furthermore, adopting regular maintenance routines can greatly lower the risk of future occurrences. By keeping your vehicle in top condition and addressing problems promptly, you can ensure that your Honda CR-V remains dependable and efficient on the road. Please like and subscribe to the channel. See you next time.